Welcome to the video lesson from Chapter 2 on segments, Lesson 3, Congruent Segments. By the end of today's lesson, you should be able to answer what makes two segments congruent. Let's start with some vocabulary. Congruent means geometrically identical. This, right here, the equal sign with the squiggly on top, is the symbol we use for congruency. Taking a closer look at what it means to be geometrically identical, two segments are congruent if and only if they have the same length. Well, let's talk about if and only if. That means it's a biconditional statement. A biconditional statement means that both the premise and the converse are true, so actually all four statements are true. And again, those four statements refer to the premise, the converse, the inverse, and the contrapositive. So when you have this if and only if, it's a biconditional statement, which essentially means that all of these are true. So two segments are congruent if and only if they have the same length. So if the same length, they're congruent. If they're congruent, then they have the same length. Now let's take a closer look at some of the terminology with definitions and some symbols and words. In a nutshell, being congruent means that they're equal in length. This piece here is read, this is why this part's in quotations. We read this as line CG, that's what the line is, line CG is congruent to line MK. You'll notice here that I'm missing the second equal to bar here. It's simply because my program that I'm using here wouldn't allow me to create that symbol. So line CG is congruent to line MK. So because they are congruent, it means that their lengths are equal in length. Lastly, segment CG is congruent to segment MK. So CG is the same measure as MK. The different symbols do mean different things. Congruency means equal in length, same measure, but you can't just say that they are equal to each other because they're not the same. Though they are the same length, they're not the exact same line or the line segment. So the different symbols do mean different things. Congruency is really just equal length in geometry. Some things I want to point out before we get started with this example. Notice the symbol I changed here. So this is true or false. Is line segment DE congruent to GH? And then B, you want to make sure it has the same thing. So you guys can add that extra line there. Line EF is congruent to FG. So remember, congruency is talking about being the same length. So let's see how long these lines are. So from D to E, it is 3 units. And from G to H, it is 3 units. So since 3 equals 3, this is true that DE is congruent to GH. Let's check out the next one. EF is congruent to FG. So from E to F, it is 3 units. From F to G, it's just 2 units. So since 3 does not equal 2, the original statement is false because EF is not congruent to FG because they are not the same length. So in example 1, you are checking for congruency, seeing if the two line segments were actually the same length. In example 2 here, you're told that these two line segments are congruent. DH is congruent to KG, which means that they have the same length, which means that the 20 is equal to 3x minus 4. Because they are congruent, their lengths are equal. Since this is a length of 20 and this is a length of 3x minus 4, we can set up this equation, 20 equals 3x minus 4, and solve it. So x equals 8. Again, for this problem, we're given that these two line segments are congruent, which means that they have equal measure. I'm going to go ahead and show you this one only because we're going to have variables on both sides of the equation. So I'm going to subtract 6x from both sides to keep my variable on the left. You can subtract the 4x if you want, but I just like to have my x value on the left side of the equation most of the time. And then when I move that x term to the left, then I need to move everything else to the right. So I finally get a pretty simple equation to solve for here, and I get x equals 4. One thing I want you to keep in mind also with these types of problems is that we were never actually told how long these segments actually are. But now that we have the value of x, we can find that by just plugging it into one of the equations for x. It doesn't matter which one because they're the same length. So it's just possible. You want to make sure that you're answering the question that's actually asked of you. And in this case, we did. We found the value of x is x equals 4. But you may also be asked to find the actual segment length, in this case, which would be 17. So that actually leads us into this example. A couple things I'm going to mark up first, again, is that this should be congruent to, so we should have that extra little line up top there underneath that, so an equal sign with the squiggly. But it does say that AD is congruent to DG, and so AD is this segment here, this 3x plus 1, and DG is the 5x minus 9. Using tick marks is a way that we signify congruency in geometry on our shapes. So I'm just going to put a single tick mark on each of those sides. And so now that we know that those two things are congruent, we can set them equal to each other, as in the last example, to find x. However, the ultimate answer is for the perimeter of the triangle. So once you find x, you're going to need to plug that back in to find the two sides and add all three sides together. So solving for x, I got 5. Plugging that 5 into just one side, I'm getting 16. So each of these side lengths is 16, and to find the perimeter, we need to add 16 plus 16 plus 10 to get 42 inches, because that's what my 10 is labeled down there.